Hi, this is Richard. I'm making a little tutorial today to explain a sort of workaround for dealing with legacy files, of which some groups have quite a number. The way I've done this is to build a small script which uses some bash commands and awk to just convert the files into what is still quite an old format, but one that's readable by the ParaView VoX-FE tool that I've had a big hand in developing. So these older files, which I'm calling version 0 after a version 0 option of the solver. Well, not really an option, it's just a version of the solver that's been around for quite a while and people are still using. It's quite basic in terms of its output. Basically what you do is you read in these two files, which if I open the sort of header file, it looks like this. So the materials are listed in the head part of the file, and all the constraints somewhere in the middle, and then kind of what is expected to happen is given at the end. And the actual model itself is given in another file, which is also listed in here in the first file, and that's just basically a set of indices which describe where each voxel is in the model. So it's basically just an index and a number. In newer versions of the software, what we decided is that having this listing at the top of the file is okay if you've only got one or two materials, but if you want to have maybe a couple of hundred, or quite a range, a variation, that makes life a bit difficult. And also if you want to be able to change your constraints, that also makes life difficult. So one of the things that we did is we took these two components, the materials and the constraints, and just put them in other files. But we also wanted to change a couple of other things too in later versions. So that's kind of how this thing developed. So we're calling this kind of version 0 as being the oldest version that we know of that's still kind of in use. And version 1 is kind of an adaptation to this. It looks very much the same, except we've taken these material properties and the constraints out and put them into a separate file. So that's a fairly dry kind of description of what's going on. Rather than trying to code that into the ParaView VoX-FE tool, we built a small kind of script file that, as I say, uses bash commands and things to just convert into a slightly more up-to-date format where these different components are separated out. And I'm going to, this video is really all about how to use that and the results of doing that. Also, as an aside, I slightly changed the output. So if this is what's actually come out of a solver, I decided that this header was a little bit unnecessary and not very useful, and all these colons weren't very useful either. So I modified the output as well a little bit, so as it were in version 1. So that's kind of what's changed on my part. Some other people introduced some other tools as well into the version 1 of the solver, being able to read HDF5 files and things like that, which I had no part of, so I don't really have a lot to say about that. But I mention them because they are there, and that there were obviously some differences that went along with that. So now that I've introduced the formats, I'll say a little bit about how this tool kind of works. You basically need to take these files in a script and run the script, giving these two files as arguments if there's a displacement file mentioned in the script file, as in down at the bottom of the file, then the script detects that, and it will also run through that to slightly change this output chain, taking out colons and so on. So I think this has probably got a version that I've already done in here before, so I'll just select those and delete them along with this directory, and I'm going to open a terminal just to show how to use this script file. And basically it's pretty simple. It's not ever so fast, but it does work pretty well. So if I just grab that directory location and drop it in there, and then I cd into that, then I need my script file, which, as it happens, I've already run it beforehand to make sure that everything works. So if I go back through these commands, I know that I'm going to find it here. So this is the actual script, and these are the two. The script header file, which is the script file, is here, and the model file I showed you a moment ago. This script could be anywhere, and obviously you wouldn't necessarily put it in a long complicated place like this. It's just that that's where my source directory happens to be. And the actual script, if I can find it on my system, looks like this. I might as well just introduce it a little, because it gives you a little description of what's going on at the top and something about the usage. So here's the actual use of the file. So you give it this name, which is BMU2 plugin, and then your script file, your model file, and then there's an optional argument for scaling. That being the case, you maybe need that because you've used a slightly different Young's modulus than probably you should have. Anyway, people requested that, so I've added that in as an option. So if you don't give it a scaling value, it just assumes a value of 1, and everything comes out as it went in, kind of thing. But basically you've got to supply these two arguments, and there's nothing wrong with opening this file just to see what's going on and how you run this thing. Obviously if you put in some random stuff into this, then it will spit out this message anyway. Okay, so if I now run back to this box that I set up here with this command, and actually enter this command and run it on this model, it tells us that it set the scaling to 1, and it ran through the files, and it's created this output in a subdirectory called ParaView VoX-FE. So it's created a totally new version of files. So the old files it left alone. These new files are ones that you can now read into ParaView. As I mentioned before, it's created these separate constraints and materials files, which if I just open one of them, it should it's slightly different format from what was there before, but it should have kept everything, all the actual values exactly the same. And yeah, so the 300, whatever the values there. Okay, and the constraints file is basically everything that's between this selection of nodes is now being put into this file, and the displacement file, which as we left it at ×1, it's just been printed out as a sort of x1 kind of suffix, and the script file now looks a little bit simpler. It's set this script version to 2 in this model. However, there's a little wrinkle that you've got to remember. The later version of the software, we actually used a PETSI based solver, and that gives slightly different output to the one that we get here. So if I look at the displacements that we've got here, it outputs it like this. It gives a number value, It gives the number of nodes correctly, but actually this value is just placed in there as a kind of dummy value. It's not actually used in the program. At least it isn't so far, so we don't really need to calculate it. And it gives this value in case that in future we might want to swap materials about or give them slightly different values. But this is actually a format that's slightly different from our PETSI based solver, so there's something else that we have to remember when we come to import that into ParaView, which we'll come to in a moment. So if I just close all these down for a second. So these, just to reiterate, these files here we can't import into ParaView because they're using this, what I'm calling version 0 kind of format. We've now switched it to what I'm calling a version 1 solver format, where it's separated these materials files out. And if I now switch to ParaView, which I believe I've got open here, so I've loaded the plugin, so the files in there, it's all empty, nothing going on. If I now go to that model, which I think that is the correct model, but in my case actually that was sort of soft linked to there. I'll probably, it isn't there at the moment, but I've released a lot of these examples as a kind of tutorial file onto SourceForge. I haven't put anything in there for this V0 model, but I intend to, so look out for it if that's if it's going to help you. I'll probably make it this more generic beam model, because this is actually some data that belongs to some people from Holyoke Medical School. But if I load that model for now, just as an example, clicking through to this, I find the script file. Everything else should happen automatically after that. I generally leave this auto apply off so that we have a chance to look through these options when I'm using ParaView, but in this case it wouldn't actually have mattered very much. But here we are loading our squirrel jaw model, which takes a second. And there we are. So the main thing then is to be able to inspect our model and to import the displacement file as well. So we use this straighten button for that, and here's our new displacement file. Click OK for that, click OK there. This is the wrinkle that I kind of mentioned earlier on. This is not what our PETSI based solver output looks like. It's just a little different, so you have to choose for this, you have to choose this ParaBMU solver output option, then click apply, which takes a moment or two to compute, and it's nearly there. And all being well, then what we should see, if we go into this, if we select this object, which it will be already selected if that's the thing we've just done, here are the values and the limits and things that we've got here. If I now choose, say, principal strain 1, and I look at the values, just in here as a bit of a guide, I can do things like this, set the range. So obviously the model's mostly blue, so that suggests we need to change the upper end. Kind of bring that down a bit. So if, say, I choose 0.1 here and then click back into the window, I'll get something a bit more useful like that. So it will actually clip everything above 0.001. And that is the end of this small tutorial. Thank you.